Okay, so starting with question 1a, find the moment. So when they say find the moment, the formula for moment is FD. That's all. So you just need the force and the distance. Now this distance, you have to be very careful because they want a perpendicular distance to the line of action. What does that mean? In layman's language, it means when you try to imagine the force being applied where it has been shown, it should produce a turning effect. For example, if imagine there is a door like this is a hole, right? So and this is another wall, so you can come and enter, right? So for you to enter, you have to push, right? So when you push at this point, the door is going to turn like this, right? So because it can turn when you apply this force, then there is moment, there's turning, moment is turning. Okay, so it means the force that is being applied is making 90 degrees with the line of action. Okay, but if you apply the force here, here you push the door like according to the arrow, it's difficult that it's going to turn because you are going to be pushing this direction. So in that case, there's no moment because the force is not at 90 degrees. Okay, so that's how it goes. So now A, find the moment. You're just going to do moment is equal to force times distance. Force is 0.5 newtons. As you can see, the pivot is here, meaning that if you push like this, it's going to turn like this. Okay, so it's going to be 0.5 as the force and distance 2 meters, which is going to be 1 newton meter. So the units for moment is newton meter for moments. Okay, 1 newton meter. The N comes from the force, the M comes from the D. Question B. Question B is the one I'm from giving the examples. When you push from here, there will be no moment. This cannot turn. Okay, so here the moment is 0 newton meter. Question C. Question C, we're pushing from here. Okay, so the distance from the pivot to where we are pushing is this. Okay, this distance. Okay, meaning from if this is 5 and this is 2, it means this should be 3, right? Think about it. You have something like this. Okay, the distance from here to here is 5, then the distance from here to here it's 2. It means this is 3, so that 3 plus 2 is 5, right? So the distance that we want is the distance from where the force is to the pivot. In this case, here to the pivot. Therefore, moment is equal to force times distance. Force is 3 newtons. Distance is also 3 meters. So it's going to be 9 newton meter. Going to question 2, find the force F if it is in equilibrium. So issues of equilibrium, you have to use the principle of moment, which says the sum of clockwise moments is equal to the sum of anti-clockwise moments, which mathematically means F1 D1 is equal to F2 D2. Okay, so now if we look at this moment here, if we take F as F1, so it will be F times the distance from where F is to the pivot is the 2 here, right? So it will be F times 2 equals F2. F2 is the 3 newtons, right? So 3 times the distance 2. The distance from the 3 newtons to the center is 6. So it's 2F, 3 times 6, 18, divided by 2. Divided by 2. So F will be 9 newtons. It's force 9 newtons. So if you want, you can be putting the letters, but if you know, force is always newtons. So once you solve, your final answer will be newtons. If it is distance, it's going to be meters. Okay, going to question B. Question B, again, the same formula, F1 D1, F2 D2. Okay, hope you can see the diagrams. So F1 is going to be F, D1 is 3, right? The distance from F to the center is 3. F2 is 2 Newton. Well, we have an issue here. There are two forces, so it's going to be this formula needs to be expanded. Okay, so we need to identify the forces on the left, the clockwise forces and anti-clockwise forces. So this F here is trying to make the beam turn like this. Okay, so this is an anti-clockwise, meaning the clock moves like this, but this is trying to turn it in the opposite direction. So it's an anti-clockwise force. So we're going to say anti-clockwise F1 D1, okay, equals clockwise, the ones that are trying to take the beam to turn like this. Okay, so it's the 2 Newton and the 3 Newton. They're both trying to take the beam this side, right? So it's the 2 Newtons, F2 times distance 2 plus F3 times distance 3. Okay, sum of the anti-clockwise equal to sum of the clockwise. Sum means adding them. Okay, so here we have only one anti-clockwise, so we're not going to add it to anything, but the clockwise we have 2. Okay, so now what is F1? F1 is F. What is D1? D1 is 3. What is F2? F2 is 2 Newtons. What is distance 2? The distance from where the 2 Newton is to the center is 3. Okay, plus F3 is 3 times distance 3, it's 1. The distance from where 3 is to the center, it's 1. So it's going to be 3F, 2 times 3, 6, plus 3 times 1, 3. So 3F, 6 plus 3, 9. Then you divide both sides by 3. Then you have 3 as your F. So it's going to be 3 Newtons. I'm not worried about the mathematics. I know you can handle. I'm just trying to show you how to come up with the equations to solve. Question C. Again, F1 D1. Oh, sorry, before we even start this, we have to identify the forces that are going clockwise and the forces that are going anti-clockwise. Okay, so this time let's start, since our F is on the clockwise, so we'll start with the clockwise, the ones that want to take the beam to go like that. So we have F times 2, okay, and 3 times 1, right? So F1, oh sorry, let me send this. Anyway, I can do it even here. So I've got F1 D1 equals, or F1 D1 plus F2 D2 equals F3 D3. So F1 is F times distance 1, it's 2, plus F2 is 3 times distance 2, it's 1. Okay, sorry, F1 is F, then F2 is 3 times distance 2, it's 1. Okay, which is equal to F3 is 5 times distance 3, it's 1, right? So it's going to be 2F plus 3, 5 times 1, 5. So the 3, you take it this side, it becomes 2F, 5 minus 3. So 2F, it's going to be equal to 2. So you can divide both sides by 2, this and this cancels. So you're going to have F is equal to 1 Newton. Okay, let's go to the other questions, these ones which talk about distance. Now it's the same formula, same approach, nothing complicated. So here we have the 4 Newtons times distance and 2 Newtons times this. So it's F1 D1 equals F2. There are just two forces here, so it's the simplest case. So F1 is 4, distance 1 is the one we're looking for. F2 is 2, distance 2 it's 8. Sorry, it's 4. So it's going to be 4D, 2 times 4, 8, divided by 4, divided by 4. this and this goes distance A divided by 4, 2 meters. Okay. Next, we look at question B. So this one is a bit complex. So we have these three forces, 1, 2, 3. So these two are saying that it should go like this, so they are clockwise. Then this one is saying that it should go like this, anti-clockwise. Okay, so we're going to say F1 D1 equals F2 D2 plus F3 D3. Okay, not neat, but okay. F1 is 6, so it's going to be 6 times D1, which is D. F2, we can take 3, okay, times D2, 1, plus F3 is 2, times D3, it's 3. So 6 times D, 6D, 3 times 1, 3, plus 2 times 3, 6. So 6D, 3 plus 6, 9. So we can divide by 6 by 6, this and this goes, D is equal to 9 over 6. When you do 9 divided by 6, it will give you 1.5 something meters. Okay, so it's the same, okay, for all these. Okay, going to question C, we do the same. So going to question C again, we have F1 and F2 and F3, three forces, right? So we're going to say F1 D1, this one is alone, equals F2 D2 plus F3 D3. So F1 is 5 times D1, it's 1. Okay, F2 is 3 times distance 2 is this one, 1, plus F3, it's 1 times distance 3, it's D. So 5 times 1, 5, 3 times 1, 3, plus D. So we're going to have 5 minus 3 equals D. 5 minus 3 is 2 meters equals D. So that's everything about moments. The last question, I'm going to solve it independently or alone because it's the most difficult question, but once you understand it, then you'll never have problems with moments.